All right, today we're going to continue on with our stats background information. And right now we're going to talk about data visualization. We've mentioned that before, and you guys did some work with that in the seminar class. And so today we're going to kind of go a little backwards, but give you the basis so that you can kind of move forward with your data analysis, and then, kind of figure out why things happen the way they do. So when we expand on our descriptive statistics, okay, we want to look at how these outliers affect the outcome of our research. We also want to look and kind of anticipate where these outliers are. We want to look at where they are and how we can just get rid of them. Because oftentimes, if you can just eliminate the outliers, your mean or your median is going to be much more realistic. And so when we look at our measures of central tendency and our variability, we can take that information and graph it so we can have a visual representation and immediately kind of see where our problems might be. Now the numbers are great, and by themselves they're important. However, if we can take those numbers and we can give them some visual definition or some visual meaning, that's much more impactful for people who are visual learners. And sometimes, just in general, it allows you to identify where mistakes might be. Because you may graph your data and immediately you say, whoa, I've done something wrong. And it saves you from having to go through the entire analysis to come up with, oh, I've made a mistake somewhere. Well, sometimes by doing these rough graphs in the beginning, it allows you to pick out where you've made mistakes and catch them before you get too far. So there's kind of the next few slides here are going to be the 10 recommendations or 10 ways to get a great figure or a great chart. And the title of this section was pretty funny, so I thought I'd leave the exact wording in there, 10 ways to get a great figure. So number one is going to be minimize chart or graph junk. And so first of all, remember that whether we call it a chart, whether we call it a graph, it's the same thing. Now chart junk, basically that's when you have all the extra bells and whistles and you go through and you try to add every single possible highlight, and add in and fly out that you can imagine that's offered on your system, whether it's Excel or SPSS. You can avoid this by keeping it simple, keeping it very direct, not going overboard with a lot of the fluff or the bells and whistles. Number two, plan out your chart before you start creating the final copy. And again, this is where having graph paper comes in handy, having an idea of what this is going to look like. If you don't want to go out and buy graph paper, you know what? You can print it off for free. www.printfreegraphpaper.com. Or, again, you can make your own. You can use Excel and scale the squares down, and you can make this as much as you want. You can make as much graph paper as you want, or as little. But you can also do this roughly with your when you can take a little, what you might call a little pilot sample, a little test run of your data, graph it, see what it looks like, and if it looks like the way you want it to, then you can go in, finish it off, and put the finishing touches on. So number three, say what you mean what you say. Don't get out of the box. Okay? Avoid clutter, using too much text. It's very confusing to the reader when you have a lot of different things going on. This would be the equivalent to someone saying you have a busy graph or a busy slide. Sometimes this is unavoidable because you want to make as many points as you can, but whenever you can try to avoid it, do so. Whenever you can eliminate a lot of the extra, eliminate it. Number four, label everything so nothing is left to the misunderstanding of the audience. And we kind of use this in the seminar class. You guys made your graph, and you put the bare minimum labeling, and everyone tried to figure out what you were trying to show. Now, most people did a great job, figured it out, you were able to do it. However, if I took the labels off those graphs, some of them would be very confusing. Some were very basic, some were very simple, which were fine. Some were a little bit more complex. But if you take the labels off those, especially one that's got a double axis going on, you really could have trouble kind of figuring out what are we talking about. Number five, a graph should communicate only one idea. So too many thoughts can be confusing. Now, when you're able to add and compare two different things using multiple axis labels, that can be helpful, but you have to be very good at labeling and identifying that data. Trying to get multiple ideas across oftentimes results in not making any sense because it's hard to get the data sets to work. Because if the numbers aren't comparable, then you're going to have the scale is going to be off the chart. You're really going to have a hard time showing anything. So be direct, make the point, not points, but make the point with the information that's provided on the graph. Okay, keep things balanced. This is a little housekeeping thing. Center your titles, your axis labels. Make sure that everything kind of looks good, looks the way it's supposed to look. Number 7, maintain the scale. So I mentioned earlier, when you're trying to compare two things and that they aren't on the same scale, it makes it very difficult because now you have something that's really, really high and really, really low, and the range on your scale is really large. So the recommended ratio is about 3 to 4, which basically results in a 3-inch to 4-inch tall graph, 3 inches wide, 4 inches tall graph. And so you can manipulate the scale on the XY axis to fit the needs that you want to show. If you want to get more detail, you can increase or you can decrease the scale so that we're really getting into what's between the numbers. So it's 1.2, 1.3, 1.4, and that can actually show on the graph. So again, you can play with that regardless of the software that you're using. Number 8, simple is best and less is more. You got to be simple but not too simplistic. We talked about that a little bit earlier. I mentioned some of the stuff in seminar class were very simple, and that's fine. They could have been a little bit better. Be very straightforward but not distracting. You don't want to distract away from the reader there. And then the charter graph should be able to stand alone. And that's something that we want to kind of hammer home is that when you make this chart, if it's labeled correctly and it has the information the way that it should be, anyone should be able to walk up and you should be able to post this on the wall and people say, wow, I know what this means. Number 9, limit the number of words you use. Again, this is a visual display of data, not a written description or a text version of what you're trying to do. And when you are having to use words or you are going to use words, leave those $13 words that you learned in class at home and put the basics and just identify what we're talking about. You don't have to, you're not trying to show people how smart you are with your graph. And number 10, a chart alone should convey what you want to say. And if it doesn't, you need to start over. The message is the focus. It's not your artistic ability and your ability to use all the cool tools on, that the software provides. So if it doesn't if it doesn't display or relay the message that you want, then start over. Now, let's move on to kind of the grassroots of where you guys were in seminar class with what you were doing, and that is talking about frequency distributions. So we're going to talk about frequency distributions and histograms, but right now, a frequency distribution, it's a method of representing how often certain scores occur. And typically these scores are grouped in intervals. And so if we look at this chart here on the left, we see a whole bunch of scores, and they're there. Those are 5 different classrooms, and those are the kids' scores. I don't know. But if we group those, it may look like this. We'll group them in intervals of 0 to 4, 5 to 9, 10 to 14, and you guys do this already. If you're coaching a team and you want to divide them up, you're going to divide them up in age, or you may divide them up into groups by height, or you may take you may be in a classroom and you say, okay, everybody with birthdays that are May, June, and July, you're together, and everybody whose birthday is October, November, December. How you group them doesn't really matter. You just have an interval, and it's a consistent interval. So if we look on that frequency row, that's basically how many numbers fall into the 45 to 49 category. And so if you look at this and you don't know anything about it, if you look at those numbers, you see that in the middle there's the most. And then it kind of gets smaller as you go up and down. And right off the bat, you should remember 7th, 8th grade science class when they talked about a bell-shaped curve. And ladies and gentlemen, that's where we're headed. But to get there, we need to know how to create it. Now, general rules for creating class intervals. Okay, number 1 is to select a class interval that has a range, 2, 5, 10, 15, 20. data points. So you have that range in mind. Now, once you select that class interval so that 10 to 20 intervals are going to cover the entire range. So there's an easy way to compute this. Okay, so in the previous example, there were 50 scores. And we picked 10 as our intervals. We wanted 10 intervals. So if we take 50 divided by 10, that gives us 5. So that means we're going to go 0 is our lowest number. So 0, 1, 2, 3, 4. That's 5 data points. Then 5, 6, 7, 8, 9. Okay, if we started at 1, we'd be 1 to 5, 6 to 10. See what I'm saying there? So once we list the class interval, we have multiples of that interval, and then the largest interval goes at the top, and the smallest goes at the bottom. And it's very, very easy to do. Now we take that information and we create a histogram. Well, a histogram, by definition, is a visual representation of the frequency distribution. Now, frequencies are represented by bars or by columns, and if we look at them, which we will in just a second, they will become very familiar. So if we were going to do this without a computer, we'd bust out a piece of graph paper, and we would label the x and y axis, and along on the x-axis we would have values at equal distance. We would identify the midpoint of each interval, and then we would draw, centered over that midpoint, our frequencies. So what it would look like is, here is our graph paper. We have our frequency, we have our interval and our midpoint over here, and then it would look like this. We center around, and we go. Remember those two, 10 in the middle, 8 on each side, and we worked our way all the way down to 1? Again, this should be very, very familiar. Very familiar. And so if we take it to the next layer, we have the frequency polygon. Well, all this is a continuous line that represents the frequencies of scores in the class interval. So basically, we take our bar chart, our frequency histogram, and then we connect the dots where that midpoint was. And so now we have a nice, almost bell-shaped curve that we've talked about. You guys know this, you've seen it, but this is how you make it. Now, we can accumulate our frequencies. And when we do that, we basically add the frequency in a class interval to all the frequencies below that interval. So, for the class interval of 0 to 4, there's one occurrence, and there's none below it. So the cumulative frequency is 1, because 1 plus 0 is 1. Now, if we go to the 5 to 9 interval, there are 2 occurrences, 1 below it. So 2 plus 1 is 3. Now, if we look on the far right-hand column here, we see our cumulative frequency, just like we had calculated, and you can calculate that all the way up to the very top. Now, the result of this might be this. Okay? That's half of a bell-shaped curve. Okay, so that this result of cumulative frequency gives us our traditional normal distribution. Okay, so when the data is normal, we call it the bell-shaped curve. You might see this as a p-plot or a probability plot. And in order to make sense of this, you may have to put it on the graph and you say, oh, I know exactly what this is. I know exactly what to do from here. This is going to be important when we start to get into details in our standard deviation. So we're doing this for a reason. Now, the God's honest truth, are we going to be making a lot of these by hand? And the answer is no. We're not. We're going to do this with a computer. We're going to be able to create our data and make nice, pretty things. However, you have to know how to organize your data to create those. Now, basic chart designs, you have bar column charts. We've gone through those. You know what they are. We looked at our line charts. We also looked at the combination of a bar column chart and a line chart. So being able to do those are important. Pie charts, again, not used very often in academic work, but they're great representations, and they can be used if done appropriately. And then more recently, you guys looked at some XY scatter stuff. This is when it's really important to look at these outliers. It really gives you an idea of where the data falls. You can insert trend lines. There's a lot of really neat things you can do with these XY scatter charts. Now, visual display of data is important. Okay, it's a skill that you have to practice. And for those of you who have gotten really good at this, it's because you practice. And the more you try to play with it and you get information and you get data and you try to put it together, that's how you make it work. You can eliminate pages and pages of text, and you can provide pages and pages of information on one slide when you are very good at visually displaying data. it definitely appeals to the visual learner. Many people are going to pick out the details of the chart that they may or may not pick out in the text. And finally, it can make an average speaker a great presenter, because when you present the information that is appealing and very eye-catching, and you're like, wow, I understand this now. When I read it, I didn't really get it, but now I do. All of a sudden, you're a great speaker. Now, I'm going to attach the visual display of data lecture back into this course. You don't have to look at it. If you're comfortable with it, that's fine. If you need to go back and look at it, review it, you don't have to. We will continue with this. We're going to practice more and more. I want you to be very good so that when you have your data from your research, you can include these. Some of you may want to present your data at the graduate summits here on campus. You may want to go to conferences and conventions and present your data. Some of you, your information is going to lend to that very, very well. I think you're going to have some good stuff. So it's always good to know this. It's never going to be a negative. It's only going to help you in the field, whichever field you choose to go into. So keep practicing, and I will be back soon with some homework. Thank you.